Hello everyone, I am Mr. Tariq, and now we will talk about the force. What do you know about the force? Look to the picture. You have a book on the table. The forces acting on it is the gravity, the weight of the book, make pressure on the table, and this make a normal force is called normal reaction. It's called normal reaction. And here you have a girl catch a spring. The forces acting on it is the weight and the tension force from the spring. And here, if you push upward, the earth will down. Look to this monkey. Here is the weight, the force, this is tension, and here is tension, the force, and here is tension, the horizontal tension, and here is a vertical tension in weight 2, and this is weight 2. And here in tension 5, and this is small body, and here is a tension, and here is the weight of the monkey. Look to the traffic light. This is the first weight, and this is second weight, and this is the distance. The weight time distance make a moment, and this is another weight, and this is the distance, and this is the center point O. Look to these boys. The first one catch a string and they make a tension, and here he fall down because the string is cut down. Here two men on a rod, and here is a string, and here is a string, and the man walked to another man. The weight of the first, the weight of the second. And here, look to this picture. If you have a hammer and a nail, and this is your hand. For analysis, we are allowed to move the force anywhere on the line of action of the force. We cannot change the angle or direction, not the point of application. So, push and pull. Push and pull. Look to this car. To find the direction of the forces acting on this car. First one, driving force, F. The second one is the weight of the car. The weight force. And the third one is the normal reaction. The weight of the car, normal reaction, N1 and N2. And the third one is the friction force. The friction force on the rod. The friction force R. The last one is the resistance of the air. Resistance. Look at the given picture. In the first picture, a boy kicks a ball and exerts a force to the ball. Two reactions: this force ball also exerts a force to the foot. In the second picture, again, the forces are shown arrows. You should be careful while drawing these arrows. Most of the students have difficulty in the point. Be careful. Forces are acted on different objects. Thus we should show them on different bodies. The explanation also answers the frequently asked question. If the forces are equal in magnitude and opposite in the direction, why they don't cancel each other? From the explanation given above, we say that they don't cancel each other because they are acting on different bodies or systems. Forces should be on the same object or system to cancel each other. Statics is a branch of mechanics which deals with bodies at rest under the action of some influence called forces. It studies the relation among these forces as well as the condition which must be satisfied to keep the body at rest. So the statics study the body when it be at rest. In such case, we call the acted forces an equilibrium system of forces, like a book on the table, and the boy on a spring, and the monkey when catch string. So the force is defined as the effect of a natural body upon another one. The natural body is one of consisting matter with non-vanishing volume. Kind of natural body. We have two kinds. The first one is the rigid body, and the second one is deformable body. The rigid body is one in which every pair of points is considered to be at a constant distance apart of all time, regardless of type of the acting forces about it. It is never deformed. The second one is easily deformed by any acting force. This is an example. So the rigid body, there is no completely rigid real solid. The fundamental concept underlying mechanics is that of a force. In dynamics, a force is defined as the influence that changes or tries to change the state of body, being at rest or uniform motion. In statics, the interest of motion study doesn't rise except due to the unfulfillment of condition of equilibrium. The effect of force that a body acts upon another change from state to state to another. This effect could be. Let's go and talk about type of forces. Number one, the tension force. If you have a ball or a body suspended by a string, then the force acting on the string is called the tension force. Number two, the pressure force. When placing a body on a table, the body acts on the table by a force called the pressure force. This force is not generated by the weight of the body, but its magnitude depends on it. Number 3, the reaction force. The reaction force, when we place a body on a table, the body acts on the table by the pressure force. In turn, the table acts on the body by another force called the reaction force. Number 4, gravitational force. Gravitational force. Everybody is attracted towards the center of the earth vertically downward by the force of gravity, which is called the weight. Number 5, attraction force and repulsion forces. This force is generated among bodies like the sun and the planets are among magnets. Number 6, the resistance force. It is a force that tries to stop the body from moving when it starts to move, like force of friction, of air, or brakes. This is called friction force, and this is called resistance of the air. Properties of forces. The effect of force depends on 3 factors. Number 1, the magnitude of force and the direction of force. Number 3, the point of action or the line of action of force. The force is a vector which passes through a given point or acts in a given straight line. The vector of the force. It is known that a vector is well defined by magnitude and direction. Force is one of familiar example of vector. The magnitude of force is measured by French system kilogram weight or gram weight or ton weight. In international system, Newton or dyne. Newton or dyne. So, 1 kilogram weight equal 9.8 Newton approximately, and 1 kilogram weight equal 1000 gram weight, and 1 dyne equal 10 power 5 negative 5 Newton. The direction of force is defined as the direction of the vector which represents this force. In the case of coplanar vectors, the direction of force could be determined by the polar angle of the vector of force. The point of action of the force. The straight line passing through the point of action parallel to the direction of the force is called the line of action of this force. For example, look to the figure. Look to the direction of force. Look to the direction of force. Look to the direction of force in the second figure. Look to the direction of force in the third one. Example number 1. If you have a force F1 100 Newton and 33 degrees, this is the direction of the force. let me draw this force as a vector. This 33 degree, and this is the line of action of force. A force of 100 Newton, scale 1 centimeter over 20 Newton. Direction 33 degree with OX anticlockwise direction.